This is the AB 9.1 to 9.4 review. Calculators are allowed on this one, but I don't think you're going to need it at all for this problem. So if we look at number 7, we again are doing separation of variables. This is just another variation on the theme, and we just got to make sure that we keep track of all of our algebra as we track through the problem. So first we'll move the y to the bottom. We'll leave the x plus 1 on the bottom on the right. Do the antiderivatives. Add the c to the right side, and if I look here I can see that I've got a y inside a log, so typically I would isolate the y as is, but when I look up here I can see that plugging in a y of 1 and an x of 0 is going to make that c really easy to compute. So I'm just going to do that now because I'll end up with c equals 0. And I'd rather work with that than try to work with splitting the exponential. So now I'm to the point where ln of the absolute value of y equals the ln of the absolute value of x plus 1. And I need to isolate my y. So again, first thing I'll do is raise both sides, make them both exponents of e, and those log naturals will cancel. The next thing I'll do is I'll move this particular absolute value. I'm just trying to isolate the y. So when I do that, I get a plus or minus absolute value of x plus 1. If I go back to my point, I need to have a positive y come out when x is 0. So that means y is just going to be the positive absolute value. And we're done. Next one, part B. Same thing, we need to isolate our variable, or excuse me, separate our variables, and again I'm only going to move what needs to come over. So I'm going to move that 1 plus y, and I'm going to leave the 1/4 and the 1 over x on the right side. Notice I'm going to pull that constant out in front so that I don't have to worry about doing the chain rule backwards. It would still work, but people tend to make errors with that constant, so I'll leave it out in front. Antiderivative of this one equals the antiderivative of the next one. Put the c on the x side. Again, if I plug in y equals 0 and x equals 1, I'm going to get c equals 0. So I'm going to do that now. So I don't have to worry about that c. Okay, if I want to get y by itself, I will first get rid of the log. Now notice that this one, the log does not disappear because I've got that 1/4. If I wanted it to disappear, I'd have to move that 1/4 into the power position, which I could do, but in the answer key I didn't, so I'm just going to leave it. The next thing I do is move the absolute value. And the last thing I do is move that 1. Now again, let's double check. When x is 1, I should be getting a 0 out for y. So if I plug in a 1 here, that exponent will become a 0, so this whole thing will become a 1. So is it a negative 1 plus a 1 that gives me the 0 that I want, or is it a negative 1 minus a 1 that gives me the 0 I want? Well, it's the plus 1, so that means y should equal the positive branch. Okay, last, part C. Again, we're going to isolate, or separate our variables. So I'll have a dy over y and a 3x squared minus a 2x dx. Integrate both sides. Add the c to the right. Think about whether I want to isolate the y first or plug in the point first. Plugging in y equals 1 and x equals 1, I end up again with that nice c equals 0. So I'm just going to plug that in right now, so that all I'm working with is this ln of the absolute value of y equals an x cubed minus an x squared. To get y alone, I will move the log first, Then I'll move the plus minus, the absolute value. And then I'll pick the one that works because I know when I plug in a 1 I should get a positive out. So again, it's a positive branch. And I'm done.